In 1859, British astronomer Richard Carrington saw a blast of white light on the surface of the sun. Campers, dozing beneath the night sky in the Colorado Rockies, woke to a display of auroral light so bright one could easily read the newspaper. Thousands of miles away, crowds gathered in the streets of San Francisco with eyes turned skyward, dazzled by the fantastic display of shimmering lights. Telegraph lines and operating stations around the world suddenly burst into flames, with sparks flying, injuring more than a few telegraph operators. What was the cause of these strange occurrences in 1859? In today's episode, we will look into the Carrington Event of 1859 and what would happen to us if it occurred today. The Carrington Event was a large solar storm that took place at the beginning of September 1859, just a few months before the solar maximum of 1860. In August 1859, astronomers around the world watched with fascination as the number of sunspots on the sun dramatically increased. Among them was Richard Carrington, an amateur astronomer in the small town of Redhill near London, England. On September 1st, as Carrington was sketching the sunspots, he was blinded by a sudden flash of light. Carrington described it as a white light flare. The day after Carrington observed the impressive flare, Earth experienced an unprecedented geomagnetic storm, with telegraph systems going haywire and auroral displays, normally confined to Arctic and Antarctic latitudes, were visible all the way in the tropics. Carrington realized that the solar flare he had witnessed was almost certainly the cause of this massive geomagnetic disturbance. This was a connection that had never previously been made. The solar storm of 1859 is now known as the Carrington Event in his honor. The flare was a major coronal mass ejection, CME, a burst of magnetized plasma from the sun's upper atmosphere, the corona. In 17.6 hours, the CME traversed over 90 million miles between the Sun and Earth and unleashed its force upon our planet. The origins of CMEs can be traced to contortions in the Sun's magnetic field, leading to dark areas or sunspots on its surface. It's from these spots that solar flares, coronal mass ejections, and other electromagnetic phenomena emerge, with potentially devastating consequences for our technological way of modern life. Sunspot activity rises and falls on an 11-year cycle, and we're currently approaching the next solar maximum in 2025. So now is a good time to look at the possibility of upcoming solar storms. There were reports of sparks showering from telegraph machines, operators receiving electric shocks, and papers set ablaze by the rogue sparks. Striking auroras dazzled spectators around the world, as auroral light shows stretched far beyond their usual ranges. The northern lights, aurora borealis, were witnessed as far south as Cuba and Honolulu, Hawaii, while the southern lights, aurora australis, were seen as far north as Santiago, Chile. For many people around the world, this was the first time they'd ever witnessed the aurora, and didn't know what to make of the spectacular light show in the skies. Many believed the end of the world had arrived. When telegraph workers returned to work the following day, the effects of the Carrington Event were still being felt, as the atmosphere was still very charged. American Telegraph Company employees found it impossible to transmit or receive dispatches. Alarmingly, they later found that they could, however, unplug their batteries and transmit messages to Portland, Maine, using only the current in the atmosphere. While solar storms rarely pose a direct threat to human life, there's a risk they can impact safety-critical systems through electromagnetic effects. From space-based communications, navigation and weather forecasting services, to electrical power distribution at ground level. It's been conjectured that a storm on the scale of the Carrington Event, if it happened today, could cause power grids to collapse, sending the planet into darkness and chaos. It would most probably create an internet apocalypse, destroying servers and mainframes, sending large numbers of people and businesses offline. Global blackouts up to years long might occur, because such an event could simultaneously damage multiple high-voltage transformers that are difficult to replace. This could in turn result in major disruptions to financial markets, banking, telecommunications, business transactions, emergency and hospital services, the pumping of water and fuel, and food transport. An event of this magnitude could spell the end of our modern society, effectively sending us back to the Stone Age, or at least the Middle Ages. The Atmospheric and Environmental Research Agency has estimated that a Carrington-class event today would result in between $600 million and $2.6 trillion in damages to the U.S. power grid alone. Luckily for us, solar storms like the Carrington event happen once every 500 years or so. Those solar storms with half the intensity of the Carrington event are more frequent, occurring about every 50 years. However, we cannot be certain when the next Carrington-level event will occur, as space weather is notoriously difficult to predict. It isn't a question of if another Carrington-type event will occur, it's a matter of when. And when it does occur, will we be ready for it? This concludes today's episode of the Paranormal Report. If you enjoyed today's episode, please give us a thumbs up and consider subscribing to our channel. It is due to your continued viewership and support that we are able to bring you interesting and informative videos like this. The team here at the Paranormal Report really appreciates your support.